Bismillahirrahmanirrahim. I am here Muhammad Tayyab from Army Public School and College Khanewal. Your class is ninth and your subject is physics and week is 5th online sport program and topic is 1 and your subject teacher is Mr. Muhammad Tayyab. Today our topic is energy and kinetic energy and our objective is at the end of the lesson students will be able to understand energy and kinetic energy. And day is 1. First of all, we will discuss our previous topic, work and energy. What is work? Work is done when a force acting on a body displaces it in the direction of force. This is called work. Work is a scalar quantity. It depends on the force acting on a body, displacement of the body, and the angle between them. And what is the unit of work? Unit of work is joule and is defined as the amount of work is 1 joule when a force of 1 Newton displaces a body through 1 meter in the direction of force. 1 joule is equal to 1 Newton multiplied by 1 meter. Next one is what is energy? A body possesses energy if it is capable to do work. Is called energy. Energy exists in various forms such as mechanical energy, heat energy, light energy, sound energy, electrical energy, chemical energy, and nuclear energy, etc. Energy can be transferred from one form to another. Now we will come back to our today's topic, kinetic energy. What is kinetic energy? Kinetic energy is the energy that object possesses due to their motion. I am again repeating, kinetic energy is the energy that objects possessing due to its motion, and the formula is kinetic energy is equal to half mv square. M is a mass that is measured in kilogram, v is the velocity that is measured is in meter per second, and kinetic energy we measure in joules. The unit of energy is joules. The energy possessed by a body due to its motion is called kinetic energy. This is the definition in your book. Now we will drive the and prove the formula of kinetic energy. You have to see that in this slides, work done. You know that the formula of work done is Fs. F is a force, S is the displacement. Due to the force, the velocity change Vf and the acceleration is A. And relationship between V, U, A and the S is equal to V square minus U square is equal to S. This is the third equation of motion. You have already read in the third chapter 2as is equal to vf square minus vi square. This is the final velocity and this is the initial velocity. And 2 and a multiply by s, then divide on other side. S is equal to vf square minus vi square. This is the final velocity and this is the initial velocity is equal to 2a. You know that the formula of Newton's second law of motion, F is equal to ma. You have already read in the second chapter, third chapter. Substitute the value 2 and 3 in equation 1, we get this value. This equation is 2 and this equation is 1. Substitute the value, then we get the answer. W is equal to F multiplied by S. We put the value F is equal to MA, F is equal to MA, then put the value F is equal to MA multiplied by, then the value of S is VF square minus VI square is equal to divided by 2A. VF square minus VI square is divided by 2A. Then W is equal to half, this is the half M. A and A cancel each other, half m v square minus vi square. And you know that the object is at rest, so we can say that vi is equal to 0. Then this equation is 0. Then we can get the answer W is equal to half mv square. Then you know that work done is equal to change in kinetic energy. Work done is equal to change in kinetic energy, and work done is equal to change in kinetic energy. And when I put the replace the value, work done is a kinetic energy is equal to half mv square. This is the formula of kinetic energy. We have already proved that. Now I will share you the animation about the kinetic energy that is more helpful to you for learn.
FM mode. Choose mode. Ix mode.
Kinetic energy. The energy with an object possesses by virtue of its motion is known as kinetic energy. Let's consider a smooth round ball. If we push the ball a little, it will be set in motion. The rolling ball, by virtue of its motion, is capable of doing work. Here it hits an object, such as a small wooden block, pushing the object a bit beyond its initial position. The energy of this moving ball is its kinetic energy. An object's kinetic energy depends on both mass and speed. Let's go back to our ball. This time, we'll place the ball on an inclined plane. If we place the ball at the top of the incline and let it go, it will quickly roll down, hitting the wooden block with greater energy than before and still pushing it forward. But note the new position of the object. This time, it has been moved farther than before. Now, let's increase the inclination of the plane and return the wooden block to its original position. Place the ball at the top of the incline, letting it roll freely downhill. The ball will hit the wooden block with even greater force, pushing it much farther. Again, note the new position of the wooden block, which was pushed much farther because of the ball's increased speed. This helps us see that the kinetic energy of an object will increase as the speed increases. Let's slightly modify our experiment. Take a larger ball and let it roll down the inclined plane. The ball will hit the wooden block with a great deal of force, pushing it much farther. From this, we can see that the kinetic energy also increases with an increase in the object's mass. If we apply an equation to what we have seen, we would say that kinetic energy is equal to half the mass multiplied by the square of the speed. This can also be written as kinetic energy is equal to half mv squared, where m is the mass of the object and v is the velocity. Kinetic energy is measured in joules. When the mass of the moving object is increased 2 times, its kinetic energy will also be doubled. When the velocity of the object is increased 2-fold, then its kinetic energy will increase 4 times. Summary: moving objects possess kinetic energy by which they can do work. The kinetic energy of an object depends upon both its mass and velocity.
Next is your example 6.2. A stone of mass 500 gram strikes the ground with a velocity of 20 meter per second. How much is the kinetic energy of the stone at the same time it will strike the ground? And the data is m is equal to 500 gram. We will convert into kg, then divide by 1000, and we get the answer 0.5 kg. And velocity v is equal to 20 meter per second. V is equal to 20 meter per second, and our formula is kinetic energy is equal to half mv square. Now we will put the value of m and v. Half multiplied by the value of m is 0.5 kg, 0.5, and the value of v is 20 meter per second, and the square is 20 square. We can simplify this value and we can get the answer 100 joule. This is the kinetic energy, 100 joule. Next is your assignment, learn and write kinetic energy on page 121 on your physics textbook. Thank you.